Hi there, welcome to the Visual MODFLOW Flex video training series. My name is Braden McNeil and I'm the lead software trainer here at Waterloo, Hydrogeologic. In this video I'll discuss the sixth step in the conceptual modeling workflow using Visual MODFLOW Flex. After defining the property zones for your model, the next step in the conceptual modeling workflow is the Define Boundary Conditions step. At this stage you'll use data objects to define the location and attribute values associated with the required boundary conditions for your model. When you proceed to the Define Boundary Conditions step, you'll have three options: defining pumping wells, defining wall boundary conditions, and defining boundary conditions. The Define Boundary Conditions option is for all other boundary conditions other than the horizontal flow boundary and pumping well packages. If you select the Define Pumping Wells option, the Create Well Boundary Condition window will open up. If you've imported a well data object into your project, you can select it from the data tree and load it in using this blue arrow button here. You'll also be able to manually enter well details using the toolbar buttons above each portion of this window. When you click OK, the boundary condition will be created and should be added into the Model Explorer under the Boundary Conditions folder. If you select the Define Wall Boundary Condition option, the following window opens up. To define the wall boundary condition, you must select the polyline to delineate the geographic location of the wall. You will also have to select two model horizons to delineate the vertical extents of the wall boundary condition. Finally, you'd have to enter a conductivity and thickness value for the wall and click OK. And once again, you should see the wall boundary condition added into the Model Explorer. Finally, you can select the Define Boundary Conditions button for all other types of boundary conditions. When this option is selected, the Define Boundary Condition window opens up here. The first step in defining a new boundary condition is to select the boundary condition type. There's a list available here in this drop-down menu. You then also have to specify a name and optionally a description for this boundary condition. You'll then define where the boundary condition object should be connected on the simulation model domain. This will determine to which model layer the boundary condition will be translated. The top option will apply the boundary condition to the top layer of the simulation domain, whereas the bottom option will apply the boundary condition to the bottom layer of the model. The intermediate option allows you to assign the boundary condition to an intermediate model layer based on a connection elevation value, which you would specify in the next step. For the top, bottom, and intermediate options, you must then specify or select a polyline or polygon data object from the data tree to delineate the boundary condition geometry or where it would be located in your model. You would select the sides option if you wish to define a boundary condition to the side face of the simulation model domain. For this option, supported boundary condition types are specified head, general head, and specified flux. When this option is selected, you'll be required to define the geometry of the boundary condition by selecting the desired sides of the simulation domain using an interactive 3D viewer. For this first example, I will assign a river boundary condition to the top of the model domain. First, I select river from the boundary condition type menu, and then I'll use the river polyline from the data tree to delineate or define the location of the river. If the polyline extends beyond the conceptual model area, it will be clipped automatically as indicated by this notification. The next step in this process is to define the actual attribute values associated with the boundary condition. As usual, this data can be assigned manually as a constant value, or the data can be assigned using a number of data objects. For example, I can assign the river stage based on my ground surface elevation, and I could also assign the river bottom elevation using a surface data object as well. When I select this data type from the drop-down menu, the From Surface button, or the button associated with that data type, will become available. When I click this, a small window will open, allowing me to select from the available data objects from the data tree and load them in using the familiar blue arrow buttons. It's also possible to specify transient attribute values by changing the first menu from static to transient. This will enable the transient data button. Clicking this will open up a table which allows me to specify values for additional time periods. I can add or remove rows from this table to add in additional stress periods to my model. When the required attribute data has been entered, you would then click Finish to finalize the boundary condition and apply it to your conceptual model. Once again, you'll see it added to the Model Explorer at the bottom left. I'll now assign a constant head boundary condition to the sides of the model domain. So I'll return to the Define Boundary Conditions workflow step by clicking it in the Workflow Navigator. I'll then click Define Boundary Condition and then select Constant Head from the Boundary Condition Type menu. Finally, I'll select Side from the menu about where to connect the boundary to the simulation domain. Now, when side is selected, the next step is to select the desired sides of the simulation domain. This is accomplished by manually selecting the desired sides using an interactive 3D viewer window. Click the Show button to display the 3D viewer. The interactive 3D viewer behaves just like any other 3D viewer. You can zoom in or zoom out, rotate, and move the displayed simulation domain using your mouse. You can also change the color of the background, show or hide the axes, and change the vertical exaggeration. Begin by creating a new zone by clicking the Create New Zone button. You then click the Start Selection button to begin selecting model sides. This will activate a selector menu under the 3D viewer which determines how the model sides will be selected. Options include global, horizontal, vertical, and facets. Each option is demonstrated briefly here. The global option selects the entire outside edge of the model domain in a single click. The vertical selector will select a vertical side of the model domain. Horizontal selects horizontal areas based on the model horizons. And finally, facets will allow you to select, make a selection delineated by the model horizons and the edges of the simulation domain. When you've selected the desired sides, click Done Selection. If necessary, you can also add a new zone to the boundary by clicking the Create New Zone button. Finally, click Next to proceed to the next step and enter actual attribute values. The sides of the domain that you've selected should be highlighted in white in this next step. Once again, attribute values can be entered in a number of ways, but for this example, I'm just going to enter them as constant values. When all of the boundary conditions for your model have been assigned, you can proceed to the next workflow step, which is to design model grids and/or meshes. Thanks for watching. Stay tuned for more Visual MODFLOW Flex training videos. For additional training resources, including user manuals and free tutorials, please visit the VMod Flex support page on our website. A link is provided in the video description.